to find the optimal loading of a generators with the penalty factors, right? So we're going to see about these things. In what actually we're just going to do now, right now, and the previous experiment we have seen about very basics about how actually we could able to find out the optimal loading of the generators, and we neglected about the transmission losses. It shows that uh, where actually energy is generated, and there itself we are just going to consuming that power. As a consumer is now nearby that very nearest point about my generator. Definitely there is no much more distance. Definitely there is no length of transmission line. Definitely we could able to consider as a zero as a transmission line losses. But while consider about one more case, possibly practically it's not possible, right? So practically it will be the generator, right? The thermal power plant or maybe electricity energy generation is somewhere, and electricity consumer, right, has a low demand, or maybe that demand power, right, or maybe consumer side. We are at the end of about 500 kilometer and with 1,000 kilometer in some case, right? We are just going to scattering over there. Definitely the power is now coming from the transmission line. So it's already traveled from the transmission line. Definitely it has its own its characteristics, right? Transmission line. Definitely there is a loss is going to be will be there. And today, actually, we are just going to considering about those losses, and we are just going to find out. In that case, we are just going to find out optimal loading of a generators. These are somewhat quite interesting, right? So compared to my previous thing, right? So neglecting of transmission losses, and we are just going to try to find out one more example, and we are just going to find out a theoretical calculation. And once we just did those theoretical calculation, we are just directly jump into Matlab, and we're just to try to type our own expression, and we're just going to getting that answers, right? We'll try today, right? And these are the test plan, right? And we're just going to see. Now I'm just going to moving into Jamboard once again. Just try to find out the Jamboard. Better I could share my entire screen, right? Maybe once again I'm just going to share my Jamboard once again. Yeah, I think my Jamboard is now visible, right? Okay. We'll see now. Let us consider about a generator. Let us consider the generator one like this, right? So we'll have about the generator G1. It will be located in somewhere here, and there's one more generator. It will be located in somewhere, right? So there is a one more generator G2, right? And both generator are connected in a bus, right? So both generator is now connected in a bus, right? Maybe so both generator is now connected in a bus, and there is a load which is now connected on my bus number 2. This is what my load, right? And this is also grounded, commonly grounded system, right? And this is the bus number one, and bus number 2. This was some simple single line power system diagram, right? We could have two things, right? So we have about two generator G1, namely called G2, and we'll have a load over here, and we'll have bus 1 and bus 2. This is what my the black light denotes that my transmission. The power which is now generated from the G1 is now traveled along through bus number 1, and it will be traveling through the, and it will reach to load. The same way, G2 generator is also going to be generated power, and it will be going to uh, satisfy the load demand. Right. This is what a small diagram, right? So where you could see this particular load is now shared, right? This particular load demand is now shared between these two generators, G1 and G2. And here you could see one thing is now you could clearly notice that this load is now connected at bus number 2, which is closely connected to generator number G2, right? Anyone just tell me this load sharing kandipa originator no issue, nothing wrong in there. அது டிமாண்டோ இல்லை ஈக்குவலோ அந்த பர்டிகுலர் லோட் மட்டும் தான் இட்ஸ் பர்டிகுலர் ஜென்ரேட்டர் இஸ் கோயிங் டு பி ரெஸ்பான்சிபிள். பட் இங்க பாத்தீங்கன்னா ரெண்டு ஜெனரேட்டர் இருக்கு, ரைட்? ஜஸ்ட் காமன் கொஸ்டின், எந்த ஜெனரேட்டர் இஸ் கோயிங் டு பி ஷேர் மோர் லோட்? எனிவன்? எந்த லோட் வந்துட்டு மேக்ஸிமம் லோட் வந்து ஷேர் பண்ணிக்கும் இந்த லோட்?
G2.
G2. Why pa? Why? It's absolutely right answer.
Closer to the load and connected
Yeah.
to the same bus.
Yeah, connected to the same bus and it will be near to this my generating station. Even though we'll have one more case also will be there, right? So for example, one more case. Let us consider this case. 500 megawatt load. Let us consider this one more example. 500 megawatt load, and we'll have about two generators, right? Let us consider about this. What about um, 600 megawatt G1 generator? Let us consider, and this what about 300 megawatt. Now you could see this is the biggest generator and this was a somewhat moderate small generator. நல்லா வாட்ச் பண்ணா இதோட 50% தான் இது it will be double the rate. இப்போ சொல்லுங்க, in this case எப்படி வந்துட்டு லோட் ஷேரிங் நடக்கும்? ஜெனரலி ஸ்பீக்கிங், நாட் மேத்தமெட்டிக்கல் ஈக்குவேஷன்ஸ், ஜெனரலி ஸ்பீக்கிங் எப்படி லோட் ஷேரிங் இருக்கும்னு நினைக்கிறீங்க? With your first answer.
300 from G2 and 200 from.
Yeah, absolutely. 300 will be going to be applied from the here. 300 will be generated over here. It will be around, not actually full load. It will be around 270 megawatt, right? So nearby 300, right? And the remaining load is now going to be coming from G1. Why actually in the sense நீங்க கொஸ்டின் கேட்கலாம், சரி இது 600 மெகாவாட் இருக்குல்ல, அப்ப இங்க இருந்தே எடுத்துக்கலாம்ல, இதோட பிகஸ்ட் ஜெனரேட்டர்னா, then you could able, why you couldn't able to bring it over here? So it's, there is one big issue actually. You could see the load is now located on my nearby generator station 2. There is no issue because there is no much more line, right? So in the power which is now generated from plant 2, it will not going to travel much longer distance because it will be, the load is now nearly connected, so you could easily remove that power loss, right? So you could able to neglect, you could able to, what could I say, you could able to easily what could I say, remove this power loss, right? And the same way, if you're just going to having this idea in the sense, right, in generator 1, if you're just going to generate much power, and actually just need to travel, you need to send the power about this much distance. It will took this much distance, in the sense definitely the transmission loss, it will be very high also, right? So the power loss is also going to be getting like, once the power loss is getting high, definitely our efficiency also is going to be getting down. The same way, coal firing rate, coal buying rate, and everything is now going to be much high. The entire system is going to be, what could I say, it will be not a cost efficient one. That's why where actually load is now located, and based upon that, and then the load is now going to be getting shared, right? So from that, who actually, how many generations are there, it will be going to be calculated. This is not one more smallest idea. The same thing actually we are just going to see today classes, right? So the same kind of things we're actually just going to analyze, right? So we'll see now the same thing. I'm just going to once again try it once again. Just note it down. This is a problem now in our manual itself is given. We will just going to continue with this same problem. Generator 1, note it down, and this is what a generator number 2, G2, right? So we'll have a bus, right? We'll have a bus 1 and bus 2. So bus number 1 and bus number 2, okay, note it down. And now this name called PG suffix 1, power generated from generator 1, it denotes the PG1. This is what PG2, right? And now we'll have about the transmission, we'll have about a load over here which is connected at my bus number 2 will be here. This is what my load, power demand, or maybe load, right? So load, simply call it as load. And we'll have about one more information also is now given in our problem. 100 megawatt which is now going to be travel from bus 1 to bus 2. That shows that the power which is now generated from PG1 is now 100 megawatt, which is now generated over here, and it will be sent back into my travel system, and it will be going to be this 1 to 2. The power is now traveling, and power loss also they just given about 10 megawatt. So these are the data which is now given in our problem. Anyway, I'm just going to share my entire screen, then you could easily understood manner itself. 1 second. I think my entire screen is now visible, right? Or maybe whiteboard, Jamboard.
No,
I
sir.
think so.
Only the Jamboard is visible.
Yeah, yeah. Okay. Now you could see my entire screen. Yeah, right now. Now this is a manual problem, right? So in our fifth program, Matlab program to find out optimal loading of generated product, right? So a two-bus system is shown in figure about 100 megawatt, which is now transmitted from plant 1 to plant 2, and about transmission loss is about 10 megawatt. Find the required generation of each plant. This is what a question right now, right? We people need to find out generation of each plant and the power induced by the system, where lambda is now constant is now about 25 megawatt hour, right? So these are the data which is now given. So lambda, which is now 25 rupees per megawatt hour. These are the data which is now given in our problem, and remaining things also is now given, that is incremental fuel cost. Just note it down, incremental fuel cost also given. So we people already discussed about cost function about each and every plant, right? So each and every plant it has its own heat and curve as well as a cost curve. Here they just given in the form of uh, incremental cost, right? So the cost is which is now going to be changing with respect to power generation, right? So if I have, for example, this is what a generator station. If I'm just going to changing the power, right? So based upon my load, right? So we could see that load curve. So morning 6 a.m. to evening 6 a.m. or next a.m. to next 6 a.m. to 6 a.m. to 24 hours. The load curve will be look like this, right? So it will be somewhat peak and low. It will be dead and low, right? So each and every time the generated is going to be generate different value, right? So megawatt. It shows that the coal firing rate is also going to be changing based upon my generation of electricity energy. That's why cost function is also getting changing with respect to power, right? That is a differentiation with respect to dpg, right? So this is what a incremental cost function, right? That's why the given problem itself, this is given incremental cost function, right? So it's going to be changing with respect to power generation with respect to cost, right? So note it down. So dc1 about my generator 1 dc1, and the power which is now generated from the generator 1 is now dpg1 equal to given என்ன கொடுத்திருக்காங்க 0.02 0.02 pg1 pg suffix 1 plus 16 rupee, equation number 1. So this is the incremental fuel cost about my generator pg1 is now given. The same way we're having about two plant, right? Now we'll have about tc2, but I could just go into different column, right? So we're just having about dc2 divided by dpg2 equal to what is the value of 0.04. Just note it down, 0.04 generator number pg2 plus 20 rupee, 20 rupee. This is what my second equation. So these are the data which is now given in our given problem, right? So we'll have these data. Now we'll just directly jump into our problem, right? We'll see. Solution is start. And you could see, I already told that the power actually which is now from plant 1, right, about 100 megawatt, it needs to travel about this much distance, definitely, right? So the what could I say, this much distance it needs to travel. So everything is now made up of conductor. Now I'm just going to note in the form of resistance, right? So we could see this is bus number 1. So I'm just going to call the resistance 1 value for this particular portion, right? This portion about resistance 1, and bus number 1 to 2, the resistance value will be 1 to 2. I'm just going to note it in the form of different form, and we'll have about bus number 2. The resistance value should be 2 now, right? We'll calculate this one because we're just going to calculate power loss about the whole system, right? about the whole system, not in a PG1 alone, right? So actually, the load is now connected on my bus 2, right? So that's why we need to calculate entire power system losses, right? So we'll see. There is a common formula will be available in over here, right? So total power system losses P suffix S capital L, right? So P suffix L. So power loss about total transmission about total transmission losses I 1 to N, and one more summation J 1 to N, right? So P suffix I B suffix I into J P B suffix I into N, some parents actually. Okay, now screen is visible, pa? Yeah, anyone?
No, sir.
Okay. Awesome. Now, actually, there's a second SIM card. Someone is called as his official number. That's why. Okay, now it's now right. So now you could see my screen, right? Okay, this is what my general total transmission line power loss calculation equation, right? So we maybe cross this equation in our PSOC subject, right? So in our previous semester, I guess, power system operation control. We may cross, definitely we may cross this equation, right? Total power transmission loss, right? So here, this is why you could able to calculate. And N denotes that number of bus where, right? So I1 to N, J1 to N. And P is denotes that now generators, and P denotes the transmission line constants, right? Now our transmission system is now about two bus system, right? So two bus system, and N is now 2. Just expand this equation. Now N is now 2, right? So now the entire equation will become P suffix L. Just expand it once again by 1 to 2, and J also 1 to 2, and P I B I J and PJ. Just expand it. Expand பண்ணா உங்களுக்கு என்ன கிடைக்கும்? Just expand it. For example, I'm just going to put I is equal to 1 and J is equal to 1. P1, PB1, P1, right? That is PG1, right? So denote that. So I'm just going to use it G also, right? So we're just going to need to introduce J, right? So PG1, PG1 plus. Now I'm just going to change in the value about the J value alone, right? So remain, I'm just going to have this I is equal to 1. Only I'm just going to change my J is equal to 2. There is a four combination is going to be occurring, right? So this two combination, one more two combination, right?
Yes, sir.
And P G1, I'm just going to remaining I oda value same vachukka, J oda value mattum increase பண்றேன். Now 1 2 and P G2, this will one combination, and now I oda value is now going to be getting increased to 2. Now pg2 and b21 j value is now 1 and j value is now pg1. Now we'll increasing the I value, that is one more time. So pg2 b22 j value is now getting increased, now pg2. These are the four combinations going to be occurring over here, right? This is what my total power transmission line equation about my two bus system. Right now, in our given problem, what are the given data is now given? Right, so given data is now PG1 is now 100 megawatt system. They just given this value 100 megawatt. Right now, remaining things we need to find out actually. Right, now we're just going to replace these values over here. Before into that, right? So we are just know about PG1. We are, before consolidating these things, we're just going to we're just going to finish the remaining values, right? No need to replace now itself. We're just going to consult remaining values, right? One second, wait. And now PG1 is known value and remaining, right? So remaining, what are the constant will be there over here in the sense. Here we just in the form of I'm just used resistance, right? So R1, R12, and B12. Here actually transmission line constant is now B12, B21, B11, B12, B21, and B22. These are the transmission line constants. And we'll have about PG1 power generated at generator 1 and PG2 power generated on PG2. So இதில் உனக்கு ஒரே ஒரு வேல்யூ மட்டும் தான் தெரியும், that is power generated on generator 1, right? So remaining things we don't know about those values, right? And also PG2 also we need to actually find out, but right currently we are just not having those values, right? In the same way, B11, that is bus 11, right? So over here, right? Over here, bus 11. What are the resident? What are the constants? B22 and B12, B21. We need to find out, right? So, for example, the power which is now developed at my PG2 is generated over here, and it will be transmitted immediately to this load very nearest location, right? So we could understood that there is no what could I say, so the power which is now related to B2 bus, that is a B22 bus admittance spectrum சொல்லலையே Y22 அந்த மாதிரி B22 and B21, right? Both are, I'm just going to consider as zero. There is there is no much loss is going to be creating over here. So because the generator power which is now here itself, right, it will be traveled immediately and it will be going to consumed by load. That's why I'm just going to remove these losses over here. So B21 and B22, right? So it's going to be considered as zero because much more loss is not going to be there, right? Because the load is now near to that location. That's why. அப்ப என்னென்ன term cancel ஆகுன்னு பாருங்களேன் லாசஸ்ல. You could see B22 is going to be cancelled, 0, and B21 is also going to be 0. And one more thing, B21 or B12 both are same, right? So B bus number 122, bus number 221 both are same. So this three terms is going to be getting 0 because the load is now nearly connected to my generate number 2. That's why the loss is going to be much minimum. But while coming to one more generator is also here, this generator 1 is also going to be contributing their part. Definitely, which is the power actually generated from G1 is also going to be uh, play a major role over here. The same way, the energy which is now traveled from bus 1 to bus 2 is also going to be considered. அப்படிங்கிறப்ப எனக்கு the loss is going to be much high, about B11, right? We need to consider those things. So the B11 is going to be will be there actually. It's not going to be cancelled each other, right? So it is going to be there. But you could raise a question. B12 எப்படி சார் நீங்க cancel பண்ணலாம்? You could raise a question actually over here. B11 okay, B12 answer cancel பண்ணீங்க. You could raise a question. So B1 is now known value. So B2 is now unknown value also. This is what a constant. And as well as B21, B12 is also it's equal. That's why we just moved at 0. Actually, the power which is now generated from B2, the power is not going to be traveled from B2 to P1 because the power is not only the power actually which is now generated from B2 is now going to be consumed by load alone, right? So எனக்கு power generate ஆச்சுன்னா இங்க தான் வரணும். It will not going to travel from B1 because there is no load is now connected on bus 1. அப்படிங்கிறப்ப எனக்கு power வந்துட்டு அங்க போக வாய்ப்பே இல்லை, right? Then the loss is also zero. Got idea now? Got my point? Actually, the load is now here. The power which is now generated from generator 2 is going to be flow like this. It's not going to be flow B1 to sorry B2 to P1. அப்படி போக வாய்ப்பு இல்லை, right? Because there is no load on my bus number 1. That's why the loss is also going to be, there is no loss on that particular area. We are just going to consider like that, right? Now B1 to B21 is both are 0. And
Yes.
remaining value, remaining பாருங்க என்ன இருக்குன்னு பாருங்க. So the remaining value PL equal to, what are the remaining values? Only one term I will be there, right? PG1, PG1, B11, PG1. These things only is going to be available, right? And we know the value of about BG1, right? So about our given problem PG1 is now 100 megawatt. Am I correct, right? So it will be 100 megawatt. In our given problem, this is what a 100 megawatt. So the power 100 megawatt is now transmitted from plant 1 to plant 2. That is this power, right? So PG1, right, which is generated over here. And now P suffix L is equal to 100 into B11 into 100. It will be around 10,000, right? So PL 10,000 B11. So power loss also given about 10 megawatt, right? So power loss is also, transmission loss is also about P12 to P2 is now 10 megawatt, right? Plant 1 to plant 2. And this what a loss about 10. 10 equal to 10,000 B11. What is the value for B1 now right now in our hand? So B11 equal to 10 divided by 10,000. So what is the value for B11 now? 0. This
0001.
yeah, 001, right? This value for B1. Once we just got this value, just substitute in our power transmission loss equation. Where actually that power transmission loss equation, this one, right? Just substitute this in this equation, B11 value, right? So now once we just substitute over here, so P suffix L equal to PG1 square into 0.001, right? 0.001. PG1 is now twice times to be there, 2 times will be there. So PG will consider as PG suffix 1 the whole square, right? This is what my whole transmission loss about my this system. So once again I'm just going to write it. P suffix L 0.001 P suffix G1 square. This is what a transmission loss about my whole system. Equation number B. We'll consider about equation number B. Got idea now how we just calculated about the entire transmission loss about this particular system. ஏன் PG1 இருக்கு அப்படி PG2 ஏன் வரல அப்படின்னா PG2ல transmission loss இருக்க சான்ஸ் இல்லை because this is a load is now nearly connected to that location, right? That's why PG2 is now not coming over here, right? You could easily understood over there here itself. The mathematical representation also you could able to easily understood, right? And now it's time to calculate remaining things.
Sir,
Yeah, yeah.
this one I had a doubt, sir. Like
Why? Where?
this equation, sir. The thing is, like, if they have already given us power loss and PG1, what is the use of finding this equation?
Where it should be? Where actually your voice is getting breaking. That's why. Where? This one, huh?
The last equation,
Where?
sir.
This.
Sir, are you able to hear me?
Yes, yes. This one.
Yes, sir. The last equation.
This one.
This one.
P
This one. Yes, sir.
suffix L is equal to 0.001 PG1 square.
Yes, sir.
Yeah. This will indicates about transmission losses about our whole system.
So that's my question, sir. Like for this system, they have given PG1 value and the power loss value. So what is the advantage, or why are we finding this equation?
Actually, transmission line we couldn't able to track it, right? So this is what a transmission line coefficient b11 பார்த்தோம்ல, yeah. This one it's unknown variable. With the help of this value only, we're just going to able to calculate the whole transmission loss. But that had 10 megawatt கொடுத்திருக்காங்கல்ல, 10 megawatt, that is alone P1 system. That's what
Okay,
only
sir.
for P1 system. We need to found that entire system. That's why
Okay, sir.
it will be useful, right? It will be useful for a future. We'll see one by one. We'll see.
Okay, sir.
Yeah, it's correct. The question right, right? Okay. And now we'll move into next one. Once we just arrived PL, right? We'll have one more small concepts will be over there. So already you people answered for that questions also, right? So there is a load which is now connected over here. Anyway, I'm just going to try one more time because narrative it will be somewhat difficult, right? So anyway, I'm just going to try it once again because there's a one more important concept over here. Already people given this answer also, right? Once again, we need to recall it. That's all. That's all. We'll have bus number one and we'll have bus number two, and load is also connected, right? Yeah. Yes, is what a PG1, and here it will be PG2. Okay, right, and bus number one and bus number two. So you people already told that. So generator two is going to be share much load, right? This is what I answer. Anyway, I'm just going to introduce a one more constant called L, right? So I'm just going to introduce a constant L. This is a Lagrangian factor, maybe you could call it, right? No issue. And this is a factor which is now associated with my generator two, L2. I'm just call it as L2. This is a one more name called uh, penalty factor actually, right? I'm just going to call it as penalty factor. So why in the sense this L2 is going to be what could you say, this generator 2 is going to be share more load, right? And the same way it's going to be consuming much energy cost, right? Because it's going to spend more energy. That's why the fuel cost is also going to be much more, because this generator is going to be sharing much amount of load. That's why cost factor is also much high, generating capability also much high. That's why this is actually penalty factor is nothing but the ratio between generated power, right? Generated power and the ratio between generated power to receiving power. That is my load, right? So load க்கு எவ்வளவு reach ஆகுது. This ratio is called penalty factor. இங்க வாட்ச் பண்ணீங்கன்னா generated power அப்படியே லோடுக்கு போடும். It shows the penalty factor about my what could you say about it should be less than 1. So generated power வந்துட்டு லோடுக்கு அப்படியே transmit ஆகும், right? So I think once again I just verify with that. Once again we'll verify with that. One second. One second. We'll just verify with that. Yeah. Yeah, it's penalty factor. It should be greater than unity by its incremental cost of power, which is the power, the ratio of power generated by the plant to the actual power demand, right? The ratio between my this one, right? I'm just going to confirm it once again. That's why the ratio of power generated by the plant and to the actual power demand, right? Am I correct? Right? Is it right? Okay. Right. Here, definitely, it should be less than 1, because we'll see. Here, we'll just see, we'll have it this one, right? L2 less than 1. We'll have L1 over here, right? Which is also going to be generated power. And this power is also going to be travel this transmission line. It will be going to my satisfy my power demand, that is power load, right? Definitely நல்லா வாட்ச் பண்ணீங்கன்னா தெரியும். So L1, that is a incremental maybe that a penalty factor which is now in my PG1 should be greater than 1. Why in the sense? Why in the sense it needs to what could I say account but it needs to overcome the transmission losses actually. பட் எனக்கு இங்க வந்துட்டு டிரான்ஸ்மிஷன் லாஸே இல்லை. தட்ஸ் வை என்ன பவர் ஜென்ரேட் ஆகுதோ அப்படியே நேராக வந்துட்டு லோடுக்கு சாட்டிஸ்ஃபை ஆகிடும். So that's why my L2 is now not unity, it will be less than 1. But over here, right, in my generator 1, it needs to generate much more power in order to overcome my power loss, and also it needs to satisfy the load. That's why it needs to also satisfy the load, as well as it needs to overcome the transmission losses also. That's why L1 is now much high. So in our conclusion irukku appadina, right? So these are general comparison. So incremental cost about my generator 1, I suffix C1 is denotes the incremental cost about my generator 1 is now associated with my penalty factor L1 equal to IC2 L2. This is what a condition, right? So this is what a economic condition, right? Now we already know that now L1 is now greater than 1. That is L1 is now greater than 1, L2 is now less than 1. So we could simply call it as L1 is greater than, L2 is less than. ஸோ அப்படி இருக்கிறப்ப எனக்கு எதனுடைய சிஸ்டம் இன்க்ரிமெண்டல் காஸ்ட் வந்துட்டு அதிகமா இருக்கும்னு நினைக்கிறீங்க பாத்தீங்கன்னா IC2 IC2 is now greater than IC1. Am I correct? Shall we call this like this? Because L1 oda contribution adhigam, L2 oda contribution it will be. Am I correct? Whether it
Yes,
will
sir.
be yeah, right? It will be high because IC2 why it's high, because it's going to be sharing much load. It will be very easy to understand, right? Because IC2 is why in the sense high in the sense the problem itself you could easily understood, because it will be nearly our nearest location about my load. That's why it's going to share more load in the sense more sharing load in the sense it's going to generate much more power, as well as it's going to much more power generate பண்றேன்னா என்ன அர்த்தம், more coal fire பண்றான்னு அர்த்தம், more coal will be going to in the form of incremental cost is also high, right? So one more small identification we need to identify over here, right? Got idea. Now with these information, we're just going to go with it one more step after, right? With these information, we're just going to go with it one more step, right? And at economic condition, so just note it down at economic dispatch condition, economic operation, economic maybe economic, right? So one more NO, economic operation, right? For economic operation, that incremental cost, fuel incremental cost DC1 by, we are having about two increment cost about two systems. DC1 by TGP1 incremental cost with the penalty factor is equal to the second thing, the second generator DC2 divided by TPG2 power generator capacity about my system. The penalty factor about 2, it is now equal to the lambda. This is what economic condition. But if you are just having one more generator, there is a one more incremental cost, fuel cost function which is now going to coming, and their penalty factor is also going to be coming. Then it will be going to be like Lagrangian factor about rupee constraint. This is what a economic condition operating system for any plant, any type of electricity power generation plant, right? With these only, we are just going to go with the next step. So DC1 by DPG1 is nothing but incremental fuel cost, which is given in our problem itself, right? So and equation கொடுத்திருந்தாங்க இல்லையா, those things is now called it incremental fuel cost. இது நமக்கு already known value, so no need to get calculate over here, and just simply you could able to replace over here, and you could simply replace it over here. Now it's time to calculate L1 and L2. What is L1 and what is L2? That is a penalty factor, right? So L1 is now penalty factor at my generator 1, right? What is the formula for calculating penalty factor? It will be very easiest, common formula, it will be there. Derivation பார்த்தோம்னா it will take about 10 to 15 minutes, and I'm not going to go with the derivation. Definitely people crossed power system analysis and control subjectல cross பண்ணிருப்பீங்க. So நான் derivation start பண்ணல. Penalty factor formula I'm just going to 1 second I'm just going to recall it, right? So 1 divided by 1 minus, right? So 1 divided by 1 minus DL, that that is called D power loss. I'm just going to make one more single differentiation with respect to power loss equation with respect to generator number 1 PG1, because I'm just going to calculate a penalty factor L1, which is now generator G1 PG1. That's why power loss equation I'm just going to differentiate with respect to PG1. This is what penalty factor 1 equation number C. we people already have a, power loss equation which is now P suffix L equal to 0.001 Pg1 the whole square, right? This one a power loss equation. அப்ப என்ன பண்ணனும், we need to differentiate with respect to Pg1. Once again just do it. என்ன வரும், we'll have L1 என்ன வரும், we just need to, before calculating L1 we need to calculate this one, right? So once we just found that, we're just going to replace it over here, and then you could able to easily calculate L1. Now I need to calculate dPL by dPg1. So already we have equation PL. I'm just going to call it PL equation once again over here, and we'll just continue once again. PL, what is the PL value? 0.001, 0.001 Pg suffix 1 square. This is the equation about power loss. Now we need to differentiate with respect to TPG, right? So D P suffix L divided by dPg1. Now what actually will come? So there is a power tool clear. 2 it will become front side, and it will be multiplied with 0.01. So now it will become 0.002, and it will be become Pg1. This is what I equation about my dou PL by dou PG by dPL, right? Differentiate with Pg1. Now we have just got an answer, right? So we need to now substitute this entire value, right? So we need to substitute this entire value into here, right? Then only you could able to calculate penalty factor about L1. Just now L1 now L1 become, already there is a numerator 1 divided by 1 minus this value 0.002 Pg1. Got a value now. This is what a penalty factor about my generator 1. The same way we need to calculate generator 2. Calculate it, make it first. We need to calculate L2. அப்ப L2 equation எப்படி வரும், அங்க எப்படி L1 எழுதணும், 1 by 1 minus dPL by dPg1. Now we need to calculate L2. L2 in the sense generator number 2. L2 penalty factor about generator 2. If I are just having one more generator P3, we need to calculate penalty factor L3, right? And 1 divided by 1 minus differentiation with respect to this equation dPL with respect to number generator 2. Now TPG2, this is equation number D, right? Now we'll have equation about PL. Once again I'm just going to recall it. So PL equation, because I'm not having a single paper on the easy solve panela. Here actually I'm just having a PL 0.001 Pg1 square, but in our equation there is no Pg2, right? If there is no Pg2 in the sense, definitely this entire PL equation is now going to be 0, right? That's called dPL by dPg2. It will become 0. Am I correct? Now it will be coming
Yes,
into 0. Substitute in this equation this value into my L2 equation. L2 என்ன வரும், 1 by 1 minus 0. Simply it will become 1, right? L2 is now 1. Now we'll have value about L1 L2. So L1 value கிடைச்சிருச்சு, L2 value கிடைச்சிருச்சு. L1 value also known, L2 value is also known, and economic condition என்னது, this one is a much more important thing. So நீங்க PSSC ல ஒரு biggest important 4 mark or 2 mark இருந்திருக்கு, right? So இதுல we are just going to substitute over here. So இந்த equation value தெரியும், L1 தெரியும், இந்த value தெரியும், L2 தெரியும், lambda தெரியும். Substitute every values into this equation, right? Finally,
sir.
right? Yeah.
One doubt, sir, in this equation.
Ah.
Why is it that this is represented? I mean, why is lambda represented as rupees, sir? Like, why is the constraint
Actually,
for cost?
ஆக்சுவலி பேஸ் காஸ்ட்னு சொல்லியிருப்பாங்க. இன்னொரு அதுக்கு மேலே அதிகமாக போயிடுச்சுனாலும் காஸ்ட் வந்துட்டு எனர்ஜி ஜென்ரேஷன் வந்துட்டு சேஞ்சஸ் ஆகும், அது மாதிரி சொல்லியிருப்பாங்க கான்செப்ட். நம்ம எப்படி நம்ம ப்ரீவியஸ் கிளாஸஸ்ல ஒரு ஸ்கொயர் வரக்கூடிய இன்சைடு ட்ரையாங்கிளில் சாரி இன்சைட் சர்க்கிளில் வி ஜஸ்ட் ட்ரை டு ஃபைண்ட் அவுட் மேக்ஸிமைஸ்டு ஒரு கர்வ் ட்ரை பண்ணோம் இல்லையா? திஸ் பர்டிகுலர் ஃபார் எக்ஸாம்பிள் ரேஷியோ லாம்டா நம்ம கண்டுபிடிச்சிருப்போம் அந்த ஈக்குவேஷன்லயுமே அந்த ப்ராப்ளத்திலுமே we just found a lambda value. இந்த lambda value change பண்ணீங்கன்னா, right? இந்த lambda value change பண்ணீங்கன்னா you could able to increase this circle, right? You could able to increase the circle in such a way that you could able to find out maximized one more triangle நம்ம வந்துட்டு track பண்ண முடியும். So this is what I called optimized constraint. இப்போ வந்துட்டு for example ரெண்டு generator வச்சிருக்கோம், G1 வச்சிருக்கோம், G2 வச்சிருக்கோம். For example, we'll have about 500 megawatts, we'll have about 700 megawatts. This is quite simply optimization problem, right? இது 500 megawatts, 700 megawatts. பட் பர்டிகுலர் ப்ரைஸுக்கு ரெண்டுக்குமே கோல் ஒன்று தான். இதுக்கும் கோல் எனர்ஜி தான் வாங்க போகிறோம், இதுவும் கோல் தான். கோல் வந்துட்டு பர் கேஜி சேம் ப்ரைஸ் தான். பட் எந்த அமௌண்ட்ல எந்த காம்பினேஷன்ல எனர்ஜி நம்ம எடுத்தோம்னா ப்ரைஸ் வந்து ரொம்ப கம்மியாக வரும். தட்ஸ் கால்டு ஃபியூல் காஸ்ட் ஃபங்க்ஷன் நம்ம ரெடியூஸ் பண்ண போகிறோம், மேக்ஸிமைஸ்டு எனர்ஜி நம்ம இன்க்ரீஸ் பண்ண போகிறோம். ஸோ அப்போ எந்த பர்டிகுலர் அமௌண்ட்டுக்கு, இது ஒரு 400 இருக்கலாம், இது ஒரு 300 இருக்கலாம், பேஸ்ட் அப்பான் மை டிமாண்ட் அண்ட் லாசஸ், இது மூணையும் கம்பேர் பண்ணி காம்பினேஷன்ல எந்த ஒரு அமௌண்ட்டுக்கு வந்துட்டு எனக்கு வந்துட்டு ஆப்டிமைஸ்டு எனர்ஜி வந்துட்டு நான் ஜெனரேட் பண்ண முடியும் அப்படிங்கிற பாயிண்ட்டுக்காக தே ஜஸ்ட் கிவன் இந்த வேல்யூ ஆஃப் லாம்டா கன்ஸ்ட்ரெயின்ட். அவ்வளவுதான். இங்க வந்து நம்ம ப்ராப்ளத்துல 25 கொடுத்துருக்காங்க, 25 ரூபின்னு கொடுத்துருக்கோம். 20 or 25, 25 கெஸ், 25 ரூபி, 25 ரூபி மெகாவாட் ஹவர். ஸோ இந்த கன்ஸ்டன்ட்டை we are just going to find out. ஸோ இப்போ இந்த சர்க்கிள் சொல்றோம்ல x ஸ்கொயர் பிளஸ் ஒய் ஸ்கொயர் இஸ் ஈக்குவல் டு 1, ரைட்? ஸோ இது இஸ் வாட் அ பிரைஸ். இதுக்கு மேல நம்ம மார்ஜினல் பிரைஸ் மேல நம்ம போகக்கூடாது. அதுக்கு மேல போனா நமக்கு லாஸ் தான் இருக்கும். எவ்வளவு ஜென்ரேட் பண்ணாலுமே நமக்கு லாஸ் தான். அதுக்காக அந்த ஜஸ்ட் ஒரு அமௌண்ட் கொடுத்துருக்காங்க, ரைட்? Now we'll just continue. Where we just stop, we need to substitute every value into this economic equation, right? We need to substitute every values into this equation. Just substitute over here. Maybe I need to create one more Jamboard, I guess. Okay, three more board will be there, right? And what is the equation? Dou C1 by dou PG1 into L1 equal to எல்லாத்தையும் substitute பண்ணுங்க. We'll see. I'm just going to substitute over here. Dou P1 equation வந்துட்டு 0.02 into PG1. So I need to write it smaller. So 0.02 PG1 plus 16. This value into L1, right? So this value is now into L1. This is what economic operation condition, right? Into penalty factor. Penalty but if the calculate பண்ணனும் 1 divided by 1 minus 0.02 into 1 minus 0.002 PG1 equal to second equation. Second equation, dou C2 by dou, sorry, differentiate with respect to C2 into dPG2, 0.04 PG2 plus 20, I guess, 20 into L1. This equation is equal to lambda value 25, right? So lambda value is 25. I'm just going to use this same value over here. Instead of lambda, I'm just going to use it 25. We have two expression over here, right? So now I'm just going to use it 25. Now we need to substitute the entire equations, right? So over equation நம்ம வந்துட்டு equal பண்ணிக்கலாம், right? So now I'm just going to equal to this into this one. After that I'm just going to equal to into this one into this one, right? L1 value, L2 value 1, right? So L2 ல L1 தான் நம்ம replace பண்ணிட்டோம். L2 value 1, I'm just going to replace it over here, right? Remaining we're just going to calculate it in the equation அப்படியே I'm just going to equate into 25 because 1 2 3, so both are equal. அதனால நான் equal பண்ண போறேன். So now 0.02 into PG1 plus 16 the whole multiplied into L1 value 1 minus 1.002 PG1 equal to lambda value, that is 25, right? That is 25. Just simplify this, just try to find out PG1. Just simplify this one and just try to find out the PG1. This whole multiplication I'm just going to bring into this into my right hand side. So 0.02 PG1 plus 16 is equal to 25 into 1 minus 0.02 0.002 Pg1. Just multiply 25 into this bracket. 0.02 Pg1 plus 16 equal to 25. 25 into 25 into 250. So 50 க்கு அப்புறம் 2 சைபர் போடணும் இல்லையா? 1 2 3. Maybe I'm just going to use it calculator.
0.05.
0.05. 0.05 Pg2. Sorry, Pg1. Right? And I'm just going to simplify it once again. In the Pg2, just bring it to the right left side. Just bring it this term onto left side, and we're just going to bring this 16 into my right hand side. Now it will become 0.02. In the பக்கம் plus 0.05, so 0.07, right? So 0.07 Pg1, and this 16 is now coming to this side, and it will be 25 minus 16. It will be 9, I guess, right? So 9,
Yes.
and Pg1 equal to 9 divided by 0.07. What is the value for Pg1?
128.571.
Yeah, 127.57 megawatt. It's correct. So this is the power which is now generated from a PG1 generator, right? This X நீங்க கேட்கலாம், 100 megawatts தான் சொல்லியிருந்தாங்க, but why this 28 is now coming? Because transmission loss is also going to be overcome, right? So about may generator 1. That's why this much power is now going to be generated, right? And now we need to find out PG2 also. Once we just found PG1 and PG2 எங்கிருந்து calculate பண்ணலாம்? In our economic condition equation, right? So here, this equation also is going to be equal to 25. This is a constraint, right? That's why. Now 0.04 Pg2 plus 20, I guess, right? So 20, I guess. One second, verify that. Yeah, 20, right?
Yes, sir.
Equal to 25. And just simplify it, it will be the easiest one. 0.04 Pg2 is equal to 20 minus 20, it will be 5, and Pg2 is equal to 5 by 0.04. What is the value for Pg2?
125.
Yeah, 125 megawatt. Yeah, it's absolutely right? And this is how actually the power which is now going to be generated, and it is now going to be getting shared with my load, right? Now
Sir,
about, yeah.
so could you please explain once again how PG1 is greater than 100 megawatts?
I couldn't get you, once again.
Sir, you told
This one, this
PG1
one,
is
this one.
greater. Yes. How does it become greater than 100 when the capacity itself is 100?
Yeah, because actually the capacity is not 100. Actually, they told that one small clue. Actually, they just given 100 megawatt is now transmitted. That's all. The optimal point is different.
Oh, okay, okay.
In our given problem, they just given a clue. 100 megawatt is now traveled. If so, if other, that's why the condition itself they given. If 100 megawatt is generated, sorry, if 100 megawatt is now traveled, we could see. If is 100 megawatt is traveled, the capacity is optimal point is different.
Okay, sir.
About my
Okay, sir.
25 rupee, right? So that's a small clue. Don't get
Okay, sir.
confused, right? Okay, this is not a capacity, right? If ஒருவேளை உனக்கு 100 மெகாவாட் நான் டிராவல் ஆகி போச்சுன்னா எனக்கு 10 மெகாவாட் வந்துட்டு டிரான்ஸ்மிஷன் லாஸ் இருக்கு அப்படின்னு சொல்லியிருக்காங்க. பட் யூ குட் ரைஸ் அ கொஷின். நம்ம ஃபர்ஸ்டே சொன்னோம், மோர் லோட் இஸ் கோயிங் டு பி ஷேர்ட் அபவுட் திஸ் ஜெனரேட்டர் அப்படின்னு சொல்லியிருந்தோம், ரைட்? ஸோ பிகாஸ் லோட் இஸ் நவ் நியர் டு பஸ், பட் யூ குட் சி PG1 is now 128 megawatt, but PG1 is now PG2 125 megawatt. நல்லா வாட்ச் பண்ணே தெரியும், இட்ஸ் நவ் ஓவர் கமிங் தி டிரான்ஸ்மிஷன் லாசஸ். அது டிரான்ஸ்மிஷன் அதனால வந்துட்டு 128 மூலம் காமிச்சிருக்கு, ரைட்?
Okay.
Okay, now we're just going to verify this mathematical equations into Matlab, right? So இப்போ மேனுவலா பண்ணணும் இல்லையா, we are just going to try to invoke this entire thing, right? So நம்ம என்னென்ன பண்ணுமோ இது எல்லாத்தையும் அப்படியே we are just going to copy it into Matlab, right? We'll try. Right, we're just going to try these things. என்னென்ன பண்ணுவோம், each and every steps actually we're just going to make this entire steps into MATLAB, right? So from this equation, we're just going to try it, right? Actually, in our manual, they just tried iterative method. But I'm not going to go with that iterative method. We're just going to go with that expression method, right? So நம்ம எப்படி straightforward expression use பண்ணி solve பண்ணோம் இல்லையா? The same method which actually we're just going to solve it in MATLAB today. That's what I planned today, right? So we'll see. Early morning we just tried. We actually got answer same also, right? But I didn't try it previous time. But anyway, I'm just going to try it morning. But unfortunately, we got an answer also, right? So that's why we're just going to see one more time, right? So no issue. And I'm just going to maximize the screen itself 1 second. Maybe before starting into that, today actually we're just going to finish it a fifth experiment. And Monday, I just expecting you from you people need to submit about the whole 1 to 5 experiments outputs, right? I'm just going to tell you that format, how actually people need to submit, right? So I'm just going to explain it later, right? Okay, and we are just going to continue today MATLAB thing, right? So start with that title and remaining things, you just go with it. I'm directly going with that today class, right? So clear up. I think my letters is now visible, right? Characters are visible, right? Shall I zoom it or it's enough?
Yes, sir, it's visible, sir.
Okay. So ரொம்ப ஈஸியாக தான் இருக்கும் ஒவ்வொரு ஸ்டெப் போயிடலாம் ரைட் அண்ட் நவ் clear all CLs it's now basic command which is given and next thing right in our uh, what could I say in our from Jamboard alone I'm just going to bring it out those things, right? So now we are just having about the entire problem we are just having about these things, right? Before going into that, I need to create a variables, right? So then only we could able to assign a values for that particular variables, right? What are the variables actually we are just getting over here in the sense we need to invoke those variables over in MATLAB. So first variable pg1 and pg2. These are the variables we need to create it, right? So pg1 one variable, pg2 variable இருக்கு அதெல்லாம் எப்பயே create பண்ணிடலாம் pg1 pg2 and after that uh, B11, right? So BPL and remaining things PL, PG1 and L1, L2, L1, L2, lambda, right? So these are the variables we need to create it, right, in MATLAB. Then only you could easily invoke those values later, right? So now I'm just going to create a variables over here, right? So first of all, we need to create a variables. I'm just going to use it creating creating a variables. Right, and step by step we just go. I'm not going to write everything, right? So I'm just going to only type a command. You people need to write a step 1, step 2 and title of about that particular program. Then should be it will be very easy. Or 2 years அப்புறம் நீங்க வந்துட்டு இந்த கோடிங் நீங்க பாக்குறீங்க அப்படின்னா it should be self explanatory இருக்கும், right? So அதுக்கு ஏத்த மாதிரி நீங்க டைப் பண்ணி வச்சுக்கோங்க. There is no restriction, just need to go with it. It's your own idea, right? So நீங்க எப்படி டைப் பண்ணிக்கோங்க, right? So there is no restriction that format, right? And the same you people need to save it and you people need to get a screenshot and you people need to submit as output, right? So நம்ம future பார்த்துக்கலாம், right? So now we'll just continue, right? So creating variables, the variables எப்படி create பண்றது sym systems, right? Systems space your remaining variables. So I'm just going to call different variable that is called we're just having about pg suffix 1. Anyway, I'm just going to use capital G, capital P, G1 and remaining variables in such a way that it is going to create CSYM. Yes. So it's not a restriction. You could able to create your own variable name, right? So now power G1, right? You could able to create your own thing. PG2 and remaining variables PG1 systems L1, L2, right? So system capital L1 and SYM yes L2 and remaining variable என்னன்னு இருக்கு L1 L2 கொடுத்தாச்சு P1 P2 கொடுத்தாச்சு PL we need to get PL, right? Power load systems L also we need to give it, that is PL, right? PL. And the remaining things, right? So the transmission line constants, this one, right? So B11, B12 and B21, B22, these are the 4 transmission line constant, right? We need to create it also. Since maybe in our future we'll have different problem, right? So 2 more loads will be connected at different location about my transmission line. ஸோ நம்ம பார்க்குற ஒரே இந்த ப்ராப்ளத்தில் the load is now located by nearby bus number 2. In some interconnected system, the load is now in between my bus. There is a chance, right? கண்டிப்பாக எனக்கு லோட் இங்கேயும் கனெக்ட் ஆகலாம். அண்ட் மேபி நியர்பை பஸ் ஒன்லையும் கனெக்ட் ஆகலாம். வில் ஹாவ் 3 more loads. இந்த மாதிரி டிஃபரன்ஸாக இருக்கலாம். அப்படிங்கிறப்ப எனக்கு that line transmission line constant going to be plays a major role. That's why we need to create entire constants, right? So I'm just going to call it as capital P11, right? So that's why different problem, it will have different variables, right? That's why we need to create those values also. Since B12 sims B 11 12 22 and 21, right? So sims 21, right? This is very easy, right? So நம்ம எப்படி மேத் இப்போ மேனுவலா கால்குலேட் பண்ணும்போது அப்படியே எக்ஸ்பிரஷனா இங்க மாத்த போறோம். That's all, right? It's not very difficult, right? So pg1 p11 p22 p1 t1, everything is now created, and I think it's enough, right? So more than variables we just created, right? Okay, now it's time to enter our fuel incremental cost function, right? So
சார் மேட்லாப் எல்லாம் கமாண்ட்ஸ் எல்லாம் கேஸ் சென்சிட்டிவ் வருது.
yes, case sensitive, yes.
SYMS கேப்ஸ்ல தான் போட முடியாது.
கேப்ஸ்ல போட்டீங்கன்னா ஒர்க் ஆகாது. இட்ஸ் a function actually.
ஓகே.
SYMங்கிறது ஃபங்க்ஷன். நீங்க பாருங்க டைப் பண்றப்பவே கீழே காமிக்கும், பாப்அப்ல வரும் பாருங்க. சின்ஸ் டினோட்ஸ் எஃபெக்ட்ஸ். எஃபெக்ட்ஸ்னா அவங்க டிஃபால்ட்டா ஃபங்க்ஷன் கிரியேட் பண்ணி வச்சிருக்காங்க இதுல மேட்லாப்ல. நம்ம ஜஸ்ட் we are just calling a function, that's all. அந்த ஃபங்க்ஷன் என்ன பண்ணும் அப்படின்னா கிரியேட் a symbolic variable and functions, அவ்வளவுதான். ஒரு வேரியபிள் கிரியேட் பண்ணா நீங்க ஃபியூச்சர்ல யூஸ் பண்ணிக்கலாம். அந்த வேரியபிளை வேல்யூ அசைன் பண்ணிக்கலாம். அதுக்கு நீங்க ஃப்ளோட்டிங் டேட்டாவோ இல்ல அரே டேட்டாவோ நீங்க அதுக்கு அசைன் பண்ணிக்கலாம். அப்படி உங்களுக்கு டவுட் இருக்குன்னா ஒன்றும் இல்லை அம்ரீஷ், வில் ஜஸ்ட் கோ வித் ஹெல்ப்ல போயிட்டு சிம்ஸ் டைப் பண்ணுங்க. ஹெல்ப்ஸ் SYMS வர மேபி ஜஸ்ட் என்ன கீவேர்ட் தெரியலனாலும் ஹெல்ப்னு போட்டு ஸ்பேஸ் கொடுத்து ஜஸ்ட் ப்ரெஸ் என்டர். இட் வில் பிரிங் யூ போட் டாக்குமெண்ட் பேஜ், ரெஃபரன்ஸ் பேஜ் ஃபார் சிம்ஸ். ஜஸ்ட் கிளிக் இட். வித் லைவ் எக்ஸாம்பிளோட வந்துடும், ரைட்? எக்ஸாம்பிள்ஸோட இட் வில் கோயிங் டு கிரியேட் திஸ் ஒன். அப்படி நீங்க n வேரியபிள் கிரியேட் பண்ணிக்கலாம், ரைட்? ஸோ நீங்க இன்னும் ஆன்சர் பண்ணல, கீழே டிஸ்கிரிப்ஷன் இருக்கும். Will have with examples order, right?
Okay.
Right. Okay. Sims returns a cell array of names, the symbolic variables and functions. இப்படி பாருங்க, ஃபார் எக்ஸாம்பிள் வந்துட்டு sim a அரேக்குள்ள 1 4 கொடுத்தீங்கன்னா என்ன ஆகும்? a ஓட வேரியபிள் அப் டு 4 வரல கிரியேட் ஆகும். a1 a2 a3 a4 இந்த மாதிரி கிரியேட் ஆகும், right? Okay. And we'll continue, right? Next we need to create a fuel incremental fuel cost function. Incremental cost function. Incremental fuel cost functions. Right? What are the equations, right? Anyway, in our given problem, the equations should be in on the chip, right? So dc1 by dpg1. This is what the incremental fuel cost, right? And for a generator one, I'm just going to create one more variable. For example, link fuel cost function of generator one. I'm just going to use it this variable name, right? So underscore we need to use it, otherwise it will consider as a functions, user defined functions, right? It will consider fuel cost function generator one. Then only you could easily understand, right, what actually we just given. Generator underscore one, right, is equal to what is the value now? 0.02 into capital P. Already we have created a variable, right? Capital P G1, right? And plus 16. Plus 16.
Sir,
yeah.
Shouldn't we declare this variable?
Where?
Fuel cost.
This one? This is a variable. This is a variable. This is a variable name. That's a variable name. Simple variable, right? X equal to 5. Instead of x, actually, I'm creating this much name. That's all. X equal to.
I understood that, sir. But my question is like, shouldn't we declare this first and then give the value?
Where actually?
That is, my question is, shouldn't we type SYMS sims fuel cost function generator 1?
Okay. You can do it. No issue.
But this way also it will work.
Let me try, right? Let me try. நமக்கு டைம் இருக்கும். We'll try. I think I couldn't get you exactly. That's why I'm just continuing.
My question is இப்போ முன்னாடில we have actually SYMS B11, SYMS
Uh,
B22. So
yeah,
now
yeah.
we have given the value for fuel cost function generator 1, that variable. So my question
Uh-huh.
is, shouldn't we declare that before giving that value 0.02 into PG1, shouldn't we declare that first SYMS fuel cost function generator 1 and then
Okay, I
give
guess.
that?
I think it will work, I guess. No issue. It will work. Because PG1 is now எங்கெங்கெல்லாம் நம்ம கம்பைல் பண்றோமோ அப்ப PG1 என்ன எங்க அந்த லெட்டர்ஸ் இட் will going to search and கண்டிப்பா அதை எடுத்துக்கும். No issue. நீங்க இதுக்கு ஆஃப்டர் கூட you could able to declare it. இந்த சென்டென்ஸ்க்கு அப்புறம் கூட நீங்க டிக்ளேர் பண்ணிக்கலாம். No issue. It will work, I guess. We'll try later, right? No issue. And now we need to create one more field function cost, right? So about my generator number 2. Right, so I'm just going to copy and I'm just going to paste it, right? That is the easiest method. So generator number 2, and the cost function value for that second is 0.024 actually. 0.04, I think I'm just going to hide it, right? So 0.02 and PG2, and this also is now 20, right? And now we create about two fuel cost function generators, right? And next step we need to create it about we need to go back Jambo 1 second. We create about two fuel function incremental fuel function cost we just created. And next step we need to create this one, right? Transmission power loss, total line transmission loss. We need to type this entire equation now. Total power loss. So PL, right? So PL actually we are already created, right? So no issue. And we are just going to calculate PL. PL equal to, and what is the entire equation? PG1 into B11 into, this is what entire thing, right? We need to recall over here, right? So capital P G1 multiplied by B11 multiplied by again PG1, right? That combination, right? So entire combination you need to create it over here, right? So I'm just going to copy paste. It will be easiest one. So simply I'm just going to copy and plus, and the combination is now PG11, PG12, and this also 2, and next combination will be PG2, and this also 2 1, and 1 1 1 2 2 1. Now final combination PG2, B22, PG2. Am I correct? Once again verify with that. PG1, P11, PG1, 1 2 2 1 1 1 2 2 2 2. Everything is now okay. So this is what the entire equation about my power transmission loss equation, right? And we need to create a constant for this given problem alone, right? So in the system for our system, we need to define a value for this variables, right? Otherwise it will not going to calculate. So for that purpose I'm just going to assigning a values for this particular system, right? So I'm just going to create a values, right? So இங்க வந்துட்டு b 2 2 it will be 0 for this given system, right? Maybe different system it will have different value, that's why. And b12 is now 0. So for understanding purpose I'm just typing over here. It will not going to be evaluated, right? This sentence is now going to be evaluated, right? Because of this percentage symbol. And b21 b21 is equal to also 0. Now I'm just going to use this command for this problem alone. It may be different from different problem, right? So that's why. Now I need to create these values into this equation. Then only this entire expression is going to be getting invoking, right? That's why I'm just going to reinitialize these values, right? So now I'm going to copy, paste B20, B210, B120, and PG2 is also 0, right? So now we'll try capital PG2. I think no need to create it. Once again, we'll just verify with that. once again we need to run it, then only it will be going to calculate, I guess. Yeah, okay, we'll try. And after this power transmission loss, and second we just run it, then only we could easily understood whether we're just going the right path, right? We're just going to once again we just run it. Yeah, it's now running, right? Now you could see PL is equal to B11 PG1 square. This is what the equation, right? So PL value நம்ம calculate பண்ணோம். PL is equal to PG1 P11 whole square. This is what the entire equation now we are getting, right? P11 PG1 square is we are just getting up to we are just right? Okay, no issue. Now we're just going to continue. And now we need to find out PL equation. This one, right? And we need to find out B11 actually. We need to find out B11. This B11 again, it needs to be replaced over here, and in order to we're just going to calculate entire power system losses. And it's time to calculate now B11 actually. So I think it should be B11 is now going to be calculated before over here, right? Before coming to here, we need to calculate B11, right? So B11 நம்ம எப்படி calculate பண்றோம் actually? B1 எப்படி calculate பண்றோம்? We are just going to substituting PL, and we are just going to substituting PG1 value. With the help of PG1 and PL value only, we are just going to calculate B11 with the help of PL PG1. We are just going to calculate B11. So that actually we are going to introduce one more variable that's called simple formula, that is called B11. I need to calculate over here. This value is now going to be invoking over in this equation. For the purpose, I'm just going to calculate before this equation, right? So B11 equal to என்ன கிடைக்கும்? B11 equal to B11 இந்த பக்கம் வச்சிட்டோம்னா BL divided by PG1 square. This is what the expression இப்படி கிடைக்கும் இல்லையா? Right? So now PL value, right? So we need to create it over here, right? So PL in the sense we already created for a power loss for a total system, right? So இங்க நான் மறுபடியும் PL எடுத்தனா இந்த வேல்யூ ஒர்க் ஆகாது. For that purpose, I'm just going to create a small PL over here. Just have an idea over here. Now PL மறுபடியும் எடுத்தனா இந்த variable மறுபடியும் assign பண்ணிடும். That entire expression is going to be getting wrong. That's why I'm just going to use it. Small PL is equal to 10 megawatt, right? In the same way, I'm just going to manually entering these entire values, right? So PL is now 10 megawatt. PG1 is now 100 megawatt. Now you could use PL divided by PG1 whole square, right? Got idea? Now this P1 is now going to be working over. Yeah, it's getting evaluated. So now total PL equal to PG1 the whole square divided by 10,000, right? It's going to evaluate பண்ணிக்கலாம். It may be again it's now coming like this, right? So the total PL equal to what is the value? 0.000 double zero no that name just tell me. 0.001, right? So அப்படிங்கிறப்ப எனக்கு 10,000 வந்திருக்குல, 10,000 divided by it will be become 0.001, right? Am I correct? This is correct. Once you can check it out, because in the form of ratio வந்திருக்கு, right? PG1 square divided by 10,000 about. And our float எழுதணும்னா 0.001, right? Am I correct? Correct. Yeah. Is it right? On that check பண்ணிக்கோங்க. Maybe you could able to use a double value also. You could also use double of PL. I don't think so whether it's going to be working or not, right? We'll see. Yeah, again it's now showing the same value. Why the double is not working? Maybe variable எடுத்துச்சு நினைக்கிறேன், right? So double variable எடுத்துருச்சு, right? And we need to use it over here, right? So we need to use it double over here. I don't think so double work ஆகுமான்னு தெரியல. We'll see over here. Double of this one. Yeah, it's showing are actually unable to convert expression to double array. It's showing that actually we need to create it double over individual double. I just need to create it, I think so, right? Anyway, I'm not going to use those double and individual equations, right? We'll continue, right? So I'm not going to discuss over here. We'll just see later, right? Now It's time to calculate a B11. We just calculate over here. Anyway, just going to 1 second. Check it out, right? So, tapanse penalty tapad, right? So, 1 divided by 1000. 0.001, right? Is it right? Is it correct, right? Okay, now next step, PL கண்டுபிடிச்சாச்சு. Then we need to differentiate with respect to in order to find out L1 and L2, right? We need to find out this economic operation. For the purpose, we need to find out L1 L2. So already we just feed these equations, right? So dC pi 1 by dPg1 and dC2 by dG2, we already feed it, right? So we already feed பண்ணியாச்சு. Now it's time to calculate economic operation. So for that purpose, we need L1 L2. So L1 L2 நமக்கு formula தெரியும் 1 by 1 minus dPL by dPg1. We need to calculate this one, right? So now we need to, it's time to create a penalty factor values, right? So now it's need to create a penalty factors. I'm just going to this sentence, right? And we're just going to maximize it, cut and paste it. Total power loss. That's now calculated, and now it's now time to calculate a penalty factor. Penalty factor L1, comma L2. So what is the formula for L1 actually? L1 equal to, right? So L1 is equal to 1 divided by 1 minus dPL by dPg1, right? So we need to differentiate with respect to 1 second and the dPL equation of 1 second we need to differentiate, right? So before calculating L1, we need to use a one more statement, right? So அப்பதான் நம்ம அந்த வேலையை இங்க invoke பண்ண முடியும், right? For the purpose, I am just going to use it at dPg1. Directly நம்ம L1 கண்டுபிடிக்கிறதுக்கு முன்னாடி we need to use one more steps. Where actually the equation PL, right? So here it will be PL will be here. So we'll have both a different variable. For example, we'll need one more variable. Then only could able to differentiate this equation, right? PL shall be called as one more variable. I'm just going to use it a different variable. For example, PL1. So L1 வச்சிருக்கோம். L1 data நான் கண்டுபிடிக்கவே இல்லை. L1 கண்டுபிடிக்கிறதுக்கு முன்னாடி we're just going to dPL. Okay, diff. I'm still using different variable dp by, for example, dp by d maybe pg1, right? I'm just going to use a different variable now. Now differentiate பண்ண போறேன். Differentiate this equation, right? About PL equation differentiate பண்ண போறேன் with respect to which variable? pg1. That's right, pg, that is capital P small g1, right? So the எந்த வேரியபிள் ஸ்டோர் பண்றேன்? differentiation dpg1 அந்த வேரியபிள் தான் நான் ஸ்டோர் பண்றேன். In the same way, we just need to differentiate one more second in order to calculate L2, right? So I'm just going to use it one more thing, dpg2 equal to diff of I'll say here itself, right? diff of PL comma PG2, right? And now we just able to calculate this. Once again we just run it, right? So இந்த step work ஆதான் check பண்ணிக்கலாம். Wait 1 second, we just going to run it. Yeah, it's now working, right? So differentiation with respect to TPG1 is equal to PG1 500, and manually நம்ம calculate பண்றப்ப என்ன வந்துச்சு? DPL by TPG1 என்ன வந்தது? 0.002. This one,
Yes, sir.
only 0.002 into PG1. In Matlab, where it's getting 1 by 500. 1 by 500 is nothing but 0.02, right? It's right? 0.002. It's now correct. And dpg with respect to g2 is now 0 because there is no value about by g2. So g1 illa, but totally it's now going to be getting 0 because நம்ம already நம்ம constant evaluate பண்ணிட்டோம். That's why this second thing is now L2 is now 0. Sorry, L2 should be 1, I guess, right? L1 L2 calculate பண்ணல, right? Sorry, Just now we are just going to calculate L1, L2. Now we just need to calculate L1. So what is the formula for L1? 1 divided by 1 minus 1 divided by 1 minus this variable, right? So in the variable only, in the variable under the store of in the variable it needs to coming over here. This variable is now going to be coming over here, right? அப்போ L1 calculate பண்ணும். We'll see L1 check பண்ணிக்கலாம். L1, yeah, L1 is now minus 1 divided by Pg1 5 is correct, right? Okay. In the same way, L2 we need to calculate. L2 equal to this one. Is now 0, right? So this is what 0. You could easily, okay, you could go with it, right? So 1 divided by, yeah, 1 right? So 1 minus this one, right? So TPG2 value. Anyway, that's it is 0, right? So Matlab itself it's going to be calculated about 0 and calculate 1 minus 1 by 0 is nothing but 1, right? So we'll see well L1 L2 will check பண்ணிக்கலாம். Yeah, L1 is now minus 1 by Pg1 by 100 minus 1. L2 is now 1. Okay. Now finally it's time to calculate economic dispatch function, right? So final economic dispatch operation, right? So இதுக்கு தான் நம்ம என்ன பண்றோம், பெரிய equationல we are just going to substitute over here, right? So what are the this one, right? So where actually it will be there, where is that bigger equation, right? So over here I guess, yeah, this one, right? We need to use this expression in order to we need to solve, we need to find out Pg1 and Pg2, right? Now we need to multiply L1 and we need to multiply L2. So for that purpose we need a solve function, right? So நம்ம solve பண்ணி தான் கண்டுபிடிக்கணும். நம்ம மேனுவலா எப்படி equation solve பண்ணோம் இல்லையா? Here no need to calculate mathematically and theoretically. Matlab itself it's going to calculate that function, right? So solveங்கிற function நம்ம already we have just used it in our Matlab. So solveங்கிற function direct is just going to use it over here, right? So for example, I'm just going to use it about power generator, power, maybe I'm just going to use it different variable, power. Once again, I'm just going to verify with that the morning class, right? Once again, I'm just going to check it out. Economic condition, right? So fuel cost generator 1 into L1 and L2, right? So okay, it's very easy, right? So power generator 1, power generator 1 equal to we are having about economic dissipation equation another, actually this is right. So dc1 divide fuel cost function into L1 equal to lambda, right? This is what one more thing, and we'll have one more expression, incremental fuel cost multiplied penalty factor equal to lambda. We'll have two equations, right? So equation number 1 and 2 both are equal to lambda. That's why actually individual நம்ம create பண்ண போறோம். Already we have created the equation here, fuel cost function. I'm just going to use this equation over here, right? So into penalty factor, that is L1. Just now we have calculated, right? L1. The same way, the fuel cost, the power generator about second generator, which is now power generator 2 equal to fuel incremental fuel cost we already defined in our earlier case. I'm just going to copy, and it should be multiplied with L2. It should be multiplied with L2. It should be multiplied with L2. But these things is now equal to lambda, double equal to lambda, right? Double equal to lambda. Lambda value is now 25. The same way, this is also equal to double lambda. That is the double equal to lambda 25. Right? Now we need to use a solve function, right? The morning I'm tried it over here, right? So we're just having about the solve function over here. I think solve yeah, fuel cost multiplied 25 here, right? We just solved it, right? So no issue. We just solved about power 1, right? Now we're just going to solve it. Once again, let's maximize the window, right? So now got idea economic dispatch condition, economic dispatch operation condition, right? So condition we just created it over here. That is double equal to lambda. It is what a constraint, economic dispatch constraint. So in the fuel cost function எங்க எடுத்தோம், already we have incremental fuel cost மேலே நம்ம டிஃபைன் பண்ணிட்டோம். அந்த எக்ஸ்பிரஷனை மறுபடியும் இங்க கால் பண்றோம் into L1. L1ங்கிறது penalty factor which is now associated with my generator 1. In the same way, increment cost generator 2 with associated factor penalty factor. Now it's time to calculate uh, calculating optimum loading, optimum generator loading, generator loading. So now I need to use solve function, right? So எதை solve பண்ண போறேன், இந்த entire equation தான் solve பண்ண போறேன், right? Solve this equation power generator, right? But it should be solve பண்ணது, it needs to solve, right? It needs to solve பண்ணிடுச்சு, right? So எதை substitute பண்ண போறேன், pg1, right? Solve பண்ணிட்டு இந்த வேல்யூ இங்க ஸ்டோர் பண்ணனும் இல்லையா, that's why I'm just going to use it one more variable. So that solve பண்ண variable it needs to store somewhere, right? That's called power generator one more, right? So underscore one, right? I need to create a different variable, right? That's why underscore one. The same way, second power generator 2, right? Copy, paste power generator from generator 2, it will be second 2 and pg2, right? Anyway, ratio to the answer, so I'm just convert it into double. That's all. It needs to be double. That's why double and double. I think it will work, I guess. Otherwise, we'll need to have a reference on my morning class session, right? We'll check it out. Yeah, I'm just going to run it 1 second. Yeah, it's working, right? Finally, we got an answer about power generator 1 is now 128.57 megawatt and 125 megawatt, right? About power generator 2. Right? Got idea now? Right? Yeah, just please note it down and try to. சொல்லுங்க அம்பரீஷ்.
சார் இல்ல சார், அந்த ஃபார்முலா மட்டும் ஓகே செக் பண்ணிக்கிறேன் சார்.
ஓகே கரி அம்பரீஷ், மேபி என்னோட வேரியபிள் நேம்ல கன்ஃபியூஸ் பண்ணிக்காதீங்க. நான் எனக்கு புரியுற மாதிரி போட்டிருக்கேன், இது உங்களுக்கும் புரியும், ரைட்? நோ நீட் டு கெட் கன்ஃபியூஸ், ரைட்? மேபி இதை நீங்க வேரியபிள் நேம் வேற கூட வச்சுக்கலாம், ரைட்? ஸோ மேபி என்ன வச்சுக்கலாம்னா எக்கனாமிக் அப்படின்னு வச்சுக்கலாம், எக்கனாமிக் ஜென்ரேட்டர் ஒன், எக்கனாமிக் ஃபியூவல் ஜென்ரேட்டர் ஒன்று வச்சுக்கோங்க. இது லுக் லைக் ஆப்டிமம் ஜென்ரேட்டர் லோடிங்கும் இது ஒரே மாதிரி இருக்கு இல்லையா? மேபி குட் ரீநேம் இன்டு டிஃபரெண்ட் நேம், வேரியபிள் நேம் மாத்திருங்க. அதை வச்சு ஸ்டில் கிவ் யூ கன்ஃபியூஷன், ரைட்? மேபி எக்கனாமிக் ஃபியூவல், economic underscore fuel, economic fuel 1, and that's fuel spelling, right? Fuel underscore 1 pg1, right? So pg1, just copy this one. இங்க சேஞ்ச் பண்ணீங்கன்னா எல்லா இடத்துலயுமே சேஞ்ச் பண்ணிக்கணும், ரைட்? ஸோ இங்க சேஞ்ச் பண்ணா எல்லா இடத்துலயுமே ரெஃப்ளெக்ட் ஆகணும். fuel pg2 இந்த வேரியபிள் தான் மறுபடியும் நான் இன்வோக் பண்ணணும் இங்க, ஏன்னா அந்த ஈக்குவேஷன் தான் சால்வ் பண்ண போறேன். That's why the same variable name is going to be reflected everywhere, right? So solve function it needs to be reflected. Now we will not get any confusion over here, right? Yeah, now we will not get any confusion. Now once again save it. Okay, let's save it, right? Save பண்ணிக்கோங்க. It's number 5, it's number batch 2 actually with the penalty. Morning நான் சேவ் பண்ணல, அந்த பேட்ச்ல இருக்கு. batch 1 I take it out. Home default, just run 1 second, run it. Yeah, it's now working. 128.57 125, right? Is it now working, right? Once again உங்க லேப்டாப்ல செக் பண்ணிக்கோங்க, right? ஸோ மெயினா பாத்தீங்கன்னா எந்தெந்த இடத்துல உங்களுக்கு கன்ஃபியூஸ் ஆக இருக்கும் அப்படின்னா, இந்த B1 இந்த டிரான்ஸ்மிஷன் லைன் கான்ஸ்டன்ட் கால்குலேட் பண்றப்ப தான் மேனுவலி இட் வில் கெட் யூ கன்ஃபியூஷன். But one more problem உங்களுக்கு கொடுக்குறேன், நீங்க just going to solve it. Otherwise I'm just going to refer some books. The books will have a number of problems will be there. So அதை நீங்க ஒர்க் பண்ணிட்டீங்கன்னா will not get any confusion about calculation these transition line parameters. ஸோ இது மட்டும் தான் கன்ஃபியூஷனா இருக்கும். மற்ற எவ்ரி திங் இஸ் நவ் ஈஸி. டிஃபரன்ஷியேட் பண்றது, அதை வேல்யூ பெனால்டி ஃபேக்டர் கால்குலேட் பண்றது அண்ட் சால்வ் பண்றது எல்லாமே நீங்க ஈஸியா சால்வ் பண்ணிட முடியும், ரைட்? ஸோ இந்த இந்த ப்ரொசீஜர்லாம் உங்களுக்கு தெரிய ஆரம்பிச்சிருச்சுன்னா, பிகாஸ் வி ஹேவ் ஜஸ்ட் சால்வ் அபவுட் 2 more ப்ராப்ளம் சால்வ் பண்ணியிருக்கோம். அதனால உங்களுக்கு இஷ்யூ வராது. எங்க ப்ராப்ளம் வரும்னா இந்த டிரான்சிஷன் லைன் பாராமீட்டர்ஸ் கால்குலேட் பண்ண மட்டும் தான், ஜஸ்ட் தட்ஸ் நாட் அ பாராமீட்டர்ஸ், தட் கான்ஸ்டன்ட்ஸ், ரைட்? அங்க மட்டும் தான் உங்களுக்கு இஷ்யூ வரும். ரிமைனிங் எல்லாமே நீங்க கிரியேட் பண்ணிடுவீங்க, ரைட்? ஸோ இது வந்து புக்கில் இருக்காது, இந்த கோடிங் புக்கெல்லாம் இருக்காது. வி ஜஸ்ட் ட்ரை, ரைட்? ஸோ ஆஸ் அ ஸ்டூடெண்ட் as well as நம்ம ட்ரை பண்ணது about mathematically we just tried, right? It is it now working, right? No issue. Just save it and we'll try one more problem, I guess, right? I think 15 or 50 ஆயிடுச்சு. So anyway we couldn't go with it. Anyway I'm just going to show you one more problem. Just try with it in our home, right? I'm just going to show you one more problem in our home. Try பண்ணி பாருங்க, right? So I'm just going to do it. But before into that, I'm just going to show you that our some manual, right? Some manual, they just tried iterative method. For loop base பண்ணி they just tried iterative. So நாம என்ன பண்ணிருக்கோம் இங்க directly in problem itself they just given lambda 25, right? So problem itself they given lambda is now 25. Why we are just going to go with the iterative method? Because lambda அவங்க iterative they just tried it, right? எப்படி ட்ரை பண்ணிருப்பாங்க பாருங்க. They just start with that CLC clear all bus number 2 and power demand theoretically they just calculate 237 and alpha and beta is nothing but these values, right? So in the equation clear they just tried within matrix format. In the first coefficient எல்லாமே alpha, second coefficient எல்லாமே beta ஒரு matrixல இன்வெர்ட் பண்ணிருக்காங்க, right? So alpha and beta. அதுக்கப்புறம் initial lambda value 20 ன்னு எடுத்துட்டு they just starting and this is calculated with the PG minimum value 00, PG that is called generator of maximum capability 200 200 000. இதை வச்சுட்டு they just started with that calculations. நம்ம கால்குலேட் பண்ண அதே ஆல்பா பீட்டா அதே இதுதான் கால்குலேட் பண்ணிருக்காங்க, ரைட்? பவர் லாஸ் கால்குலேட் பண்ணிருக்காங்க, லாம்டா, ரைட்? அண்ட் this finally just calculated and finally just printed it. But this will give you small confusion. என்ன பண்றாங்கங்கிறதே தெரியாது. You could see once again verify பண்ணிக்கோங்க. Definitely will get some confusion. But anyway, this command is also I'm checked it out, but it's giving the same answer 128.7. The same value we are just getting 128.5 and 125. But the power line is also going to be calculated by about 16%, 16.53 megawatt, right? So this also is working, no issue. Meanwhile just go with this command also. But why I'm not insisting this one, because this will give you about this will not give you about overall idea about this problem, right? So என்ன பண்றாங்கன்னு தெரியாது இல்லையா, right? That's why I'm just going to move with that expression method. This one you could easily understood what is happening actually here, right? So you could easily understand, okay, here variable create பண்றாங்க, fuel cost enter பண்ணிட்டாங்க. இங்க பாத்தீங்கன்னா fuel cost வந்துட்டு டைரக்டா மேட்ரிக்ஸ்ல நம்பர்ஸ் மட்டும் எடுத்துட்டாங்க. அதே fuel cost தான் 0.04 1620. பட் நமக்கு வந்துட்டு ஃபியூச்சர்ல பாக்குறப்ப என்னன்னா 20 போட்டிருக்காங்க அப்படிங்கிறது புரியாது இல்லையா? பட் ஹியர் வி ஜஸ்ட் என்டர்ட் தட் என்டையர் ஈக்குவேஷன், ரைட்? ஸோ ஈக்குவேஷன் வச்சுக்கிறப்ப யூ குட் ஈஸிலி அண்டர்ஸ்டாண்ட், ஓகே ஃபியூல் காஸ்ட் ஃபங்க்ஷன் இங்க இருக்கு அண்ட் நீங்க வந்துட்டு பவர் லாஸ் கால்குலேட் பண்றாங்க, ரைட்? பிஎல் பவர் லாஸ் எல்லாமே ஈக்குவேஷன் இந்த கான்ஸ்டன்ட் எல்லாமே இருக்கு. And after that we're just calculating this step by step, right? So you could easily understood this one, right? Okay, I think is it clear up to you, right? So Monday, while coming Monday, I'm just going to give you 1 second. While coming Monday we're just going to start about sixth experiment. While coming Monday I'm just going to convert this. I already uploaded in a PDF format. I'm just going to convert it into Word file now, and I'm just going to upload in our Google Classroom itself today, maybe within 20 minutes, right? So if people just need to right, so already we have crossed these things. நம்ம ஸ்டெப் பை ஸ்டெப் நீங்க பேரலா ஒர்க் பண்ணிட்டு வந்திருக்கீங்க, ஐ நோ. அதுக்கான ஆன்சர் நீங்க கையில வச்சிருப்பீங்க. அதர்வைஸ் ஐம் கோயிங் டு ஷேர் மை என்டையர் அந்த 5 எக்ஸ்பெரிமெண்டோட கோடிங் எல்லாமே நான் கூகுள் கிளாஸ்ல நான் வித்தின் ஒரு 20 to 30 minutes I'm just going to upload it. Just go with that and just download பண்ணிட்டு Matlabல ஓபன் பண்ணி இன்ஸ்டால் பண்ணிட்டு அந்த கோடிங்கை ரன் பண்ணுங்க. You will get output, right? So we will already verify it. And output just see. நீங்க பிரிண்ட் எடுத்தாலும் சரி, இல்ல சாஃப்ட் காப்பில வேர்ட் ஃபைல் எடிட் பண்ணாலும் சரி, டேட் மட்டும் போட வேண்டாம். I'm just going to tell you later. And finally while coming back into this result, right? ஸோ நீங்க எடிட் பண்ணுங்க. வேர்ட் ஃபைல் உங்களுக்கு அனுப்பிச்சிடுவேன், நீங்க எடிட் பண்ணிக்கோங்க. ரிசல்ட்ல எப்படி நம்ம பென்ல எழுதுவோம் இல்லையா, அது மாதிரி just try to type into the same the type of expertise has been done with manually as well as verified with Matlab program as well as Matlab simulink, right? Just type it whatever you just want and command used, right? So either apart from this command, apart from this pre-printed manual command, we also tried many things, right? So adellame neenga command used page la maybe you could add many more pages. That's why it's going to tell you like that, and it's going to give you word file. You could able to edit it, and what are the extra things we have just sent and workout problem எல்லாமே நம்ம ஒர்க் பண்ணிருப்போம். அது எல்லாத்தையும் இந்த கமாண்ட் யூஸ்ல பேக் அண்ட்ல ஒர்க் பண்ணிட்டு ரிசல்ட் தனியா பேஜ்ல பிரிண்ட் பண்ணிடுங்க. அண்ட் கமிங் பேக் டு செகண்ட் எக்ஸ்பெரிமெண்ட், இந்த மாதிரி தான் ஒவ்வொரு எக்ஸ்பெரிமெண்ட்டுக்கும் நடுவில் வேற ஜஸ்ட் யூ நீட் எம்டி பேஜஸ் கிரியேட்டட் இட். அண்ட் நம்ம என்னென்ன அவுட்புட் பார்த்து கரண்ட் எஃபெக்ட்ல நிறைய பார்த்துருக்கோம். அது எல்லாத்தையும் ஜஸ்ட் ட்ரை டு மேக் அ அவுட்புட் அண்ட் ஜஸ்ட் அந்த அவுட்புட் எல்லாமே இங்கே எனக்கு காமிங்க. எல்லாமே காமிச்சிட்டு ஃபைனலி ஒரே வேர்ட் ஃபைல மாத்திருங்க, ரைட்? ஸோ அது ப்ரோக்ராம் நம்பர் 1, ப்ரோக்ராம் நம்பர் 2, ப்ரோக்ராம் நம்பர் 3, அந்த மாதிரி ஒவ்வொரு ஃபைல கிரியேட் பண்ணுங்க, ரைட்? ஸோ கிரியேட் பண்ணிட்டு ஜஸ்ட் அப்லோட் இன் அவர் கூகுள் கிளாஸ். நான் அசைன்மெண்ட் கிரியேட் பண்ணிடுவேன். அசைன்மெண்ட் டாபிக் 1க்கு கீழே ஒரு அசைன்மெண்ட், அதை நீங்க அப்லோட் பண்ற மாதிரி இருக்கும். அதில் வந்துட்டு எக்ஸ்பெரிமெண்ட் நம்பர் 1 மட்டும் நீங்க அப்லோட் பண்ற மாதிரி இருக்கும். அண்ட் ஐம் கோயிங் டு கிரியேட் அசைன்மெண்ட் 2 அண்ட் டாபிக் அண்ட் சிஜிஆர். அதில் நீங்க வந்துட்டு என்ன பண்ணிருப்பீங்க, இந்த செகண்ட் எக்ஸ்பெரிமெண்ட்டுக்கான அவுட்புட் எல்லாமே வச்சிருப்பீங்க இல்லையா? இது எல்லாத்தையும் இந்த எக்ஸ்பெரிமெண்ட் பர்டிகுலர் பேஜ் நம்பர் 10 to 15க்குள்ள ஆட் பண்ணிட்டு அந்த பர்டிகுலர் ஃபைல் மட்டும் நீங்க எக்ஸ்பெரிமெண்ட் 5ன்னு சேவ் பண்ணி எனக்கு அந்த அசைன்மெண்ட் அப்லோட் பண்ற மாதிரி இருக்கும், ரைட்? ஸோ 2 days லீவ் இருக்கு, ஜஸ்ட் கோ வித் இட். உங்களுக்கு பேர்டன் இருக்காது, ரைட்? ஸோ ஒரு 5 எக்ஸ்பெரிமெண்ட் முடிஞ்சிச்சுன்னா அதுக்கப்புறம் 4 எக்ஸ்பெரிமெண்ட்ஸ் தான் இருக்கு. உங்களுக்கு பேர்டனாகவும் இருக்காது, ரைட்? ஸோ லேபரேட்டரி முடிச்ச மாதிரியும் ஒரு ஃபீல் இருக்கும், ரைட்? ஸோ 5 எக்ஸ்பெரிமெண்ட்ஸ் கம்ப்ளீட் பண்ண மாதிரி இருக்கும், ரைட்? So Monday, before coming to class, finish it up, right? So I'm just going to within over half an hour, I'm just going to create topics, assignments, and I'm just going to uploading whichever just we discussed over here. I'm just going to upload it, right? So I think we'll wind up to over here, right? So with before 10 minutes alone, we're just going to want over here, right? So any doubt? Wind up
Excuse
no?
me.
Yes, pa?
Sir, for this manual, under commands, you should we paste the screenshots of the.
Yeah. That's why I'm asking. Whatever you just worked it, right? So நீங்க வந்து அவுட்புட் வந்திருக்கு, நீங்க ஒர்க் அவுட் பண்ணுங்க. ஒரு சில சம்டைம்ஸ் அவுட்புட் வராம கூட இருக்கலாம். எல்லாமே அவுட்புட் மேக்ஸிமம் 100% அவுட்புட் நம்ம வச்சிருக்கோம் எல்லாத்துக்குமே. சப்போஸ் உங்களுக்கு ரன் டைம்ல ஏதோ எரர் வருது அப்படின்னா கூட நீங்க பேனிக்லாம் ஆக வேண்டாம். யூ ட்ரைட் இட், ரைட்? ஸோ அதை நீங்க ஸ்கிரீன்ஷாட் எடுங்க. அதுதான் இட்ஸ் மை ஓன் விஷ், ரைட்? நீங்க வந்துட்டு இன்னொரு ஸ்டூடெண்ட் வந்து காப்பிலாம் பண்ண வேண்டாம். உங்ககிட்ட இருக்கிறத நீங்க அப்படியே ஸ்கிரீன்ஷாட் எடுத்து எனக்கு காமிங்க போதும், ரைட்? ஓகேப்பா. அப்புறம் இங்க கமெண்ட் இருக்குல்ல, இங்கேயும் இங்க ஒரு பர்சன்டேஜ் சிம்பிள் யூஸ் பண்ணிட்டு உங்க நேம் போட்டுக்கோங்க. உங்க நேம் டைப் பண்ணிக்கோங்க, ரோல் நம்பர் இங்கே சம்வாட் இட் வில் பி யூனிக், ரைட்? ஸோ ரோல் நம்பர், ரெஜிஸ்டர் நம்பர் இந்த மாதிரி கிரியேட் பண்ணிட்டீங்கன்னா சம்வாட் யூனிக்கா இருக்கும், ரைட்? ஓகேப்பா. இந்த மாதிரி கிரியேட் பண்ணிட்டு அதை நீங்க வந்துட்டு சேவ் பண்ணிக்கோங்க. அதை அப்படியே ஸ்கிரீன்ஷாட் எடுத்தீங்கன்னா இட்ஸ் ஷோஸ் சம் யூனிக் கண்டென்ட், ரைட்? நீங்க டைப் பண்ணிருக்கீங்க அப்படிங்கிற மாதிரி ஒரு நல்லா இருக்கும். நீங்க தான் டைப் பண்ணிருக்கீங்க, நோ இஷ்யூ, ரைட்? ஓகேப்பா. ஓகே
Sir,
யா
we give the screenshot of both Simulink and Matlab code.
அது நீங்க என்ன நீங்க 10 ஸ்கிரீன்ஷாட் இருந்தாலும் ஐ அம் ஹாப்பி. இட் ஷோஸ் தட் யுவர் ஒர்க், ரைட்? ஸோ நாளைக்கு யாராவது கொஸ்டின் கேட்டோட குட் ஏபிள் டு டிஃபெண்ட் இட், ரைட்? ஸோ திஸ் மச் திங்ஸ் ஐ ஹவ். அவங்க நிறைய பேர் கேட்பாங்க, ஆன்லைன்ல நீங்க என்ன பண்ணிருப்பீங்க அப்படின்னு நிறைய பேர் கொஸ்டின் கேட்கறது சான்ஸ் இருக்கு, ரைட்? ஸோ அப்படிங்கிறப்ப குட் ஏபிள் டு டிஃபெண்ட் இட். எல்லாமே சொல்ல